Settle in. Let your body grow heavy and your breathing slow. Tonight we are going to tell the story of a single thing, the ground beneath you, the planet you are lying on. It seems so solid, so permanent, so simply there, that we almost never think of it as having a story at all. But the Earth is not a stage that life plays out upon. The Earth is a character, the oldest one there is for us, with a life of its own that runs back 4.5 billion years. Tonight, slowly, from the very beginning, we will follow that life. There is no hurry. Let the long, slow story of the world carry you towards sleep. It begins, as our other stories have, in a cloud of dust and gas drifting in the dark, the leftover material around a young star, our newborn sun. We have followed this moment before, from the sky's point of view. Tonight we follow it from the ground's. For in that spinning disk of debris, grain by grain, our world was gathering itself together. Dust stuck to dust. Pebbles clumped into boulders, boulders into mountains, mountains into worldlets, each pulling in more with its growing gravity, until one of those growing bodies, in the warm inner region of the disk, became the Earth. We know almost exactly how long ago this was, and the knowing is itself a small triumph of the human mind. In the 1950s, a scientist named Claire Patterson found a way to read the age of the Earth in the lead locked inside ancient meteorites, fragments left over from the very birth of the solar system, unchanged since the beginning. By measuring how their elements had slowly transformed over the ages, he arrived at a number that has held ever since. The Earth is about 4.5 billion years old. 4.54 billion years. That is the age of the ground beneath you, a span so vast that all of human history, all of recorded time, is less than the final breath of it. The newborn Earth was nothing you would recognize and nothing you could survive. It was a world of fire, a glowing ball of molten and half-molten rock, still red-hot from the violence of its own making, its surface a sea of lava under a sky of choking vapor. There were no oceans, no continents, no air to breathe, and it was still being bombarded relentlessly by the leftover debris of the solar system, a rain of rock and iron from the sky, each impact adding its heat to the furnace. Scientists named this first hellish age of the Earth the Hadean, after Hades, the underworld. It was, quite literally, hell, a molten, bombarded, airless world glowing dully in the dark. And yet, even in that fire, the Earth was already sorting itself out, settling into the layers it still has today. The heaviest material, iron and nickel, sank molten toward the center, gathering into a great metal core where it remains still hot, still churning to this day. The lighter rock floated above it, forming the thick mantle and eventually a thin skin of crust. The world was organizing itself by fire and gravity into the layered planet you are lying on, a metal heart, a rock body, a fragile skin. There is one astonishing survivor from that earliest time, a witness to the Hadean that we can actually hold in our hands. In the ancient rocks of Western Australia, geologists have found tiny crystals called zircons, grains often smaller than a grain of sand, that formed more than 4 billion years ago and have endured impossibly ever since. They are the oldest known pieces of the Earth, older than any rock, tiny time capsules from the world of fire. And what they whisper to us is a surprise, that even in that early hell, there may already have been cooler patches, and perhaps even water. The world may have begun to calm sooner than we ever guessed. So picture it now, as you drift. A young, molten world, glowing in the dark, wrapped in steam, pelted by falling stone, its iron heart sinking toward the center. The Earth, 4.5 billion years ago, at the very beginning of its long life. It is fierce, and it is new. But it will cool, as everything in these stories cools, and it will change beyond all recognition. In the next chapter, the young Earth suffers the most violent day it will ever know, and gains the moon. For now, breathe slowly, and rest at the fiery beginning of the world. While the Earth was still young and molten in the chaos of the early solar system, it suffered the most violent thing that has ever happened to it. A catastrophe so enormous it nearly destroyed the world, and yet gave us the gentle companion that has lit our nights ever since. The geologist Robert Hazen has a wonderfully blunt name for it, the Big Thwack. We usually call it the giant impact. Either way, it is the story of the day the Earth was struck by another planet. In those early days, the space around the young sun was still crowded with worlds in the making, not just the planets we know, but other bodies, half-formed, sharing crowded orbits on paths that could not all last. And one of them, a body about the size of Mars, was on a collision course with the Earth. Scientists have given this doomed world a name, Theia. The two were bound to meet, and one day, early in the Earth's life, they did. It was not a glancing blow. Theia struck the young Earth in a colossal, world-shattering collision, two planets meeting at tremendous speed. The energy released was almost beyond imagining. Theia was destroyed utterly, and much of the Earth's own outer material was blasted free, hurled up into space in a vast, glowing spray of vaporized and molten rock. For a time, the Earth was a wounded, half-liquid ruin, wrapped in a ring of its own shattered substance, spinning furiously in the dark. It is hard to picture a more violent day, and out of it came something beautiful. For that ring of debris, flung into orbit around the battered Earth, did not simply drift away. Under its own gravity, it began to gather, the countless fragments colliding, clumping, pulling together, and over a surprisingly short time, in the same way the planets themselves had formed, it assembled into a single round body circling the Earth, the Moon. Our Moon was born from the wreckage of the day another planet struck our own, made, in a real sense, from the blended remains of both the young Earth and the destroyed Theia. It is a child of catastrophe, and it has been with us ever since. The Moon we know tonight was born much closer to the Earth than it is now, looming vast in that early sky, and it has been slowly drifting away ever since, a little farther every year, so gradually we would never feel it. But its presence has shaped the whole story of our world in ways we rarely think about. The Moon's steady pull raises the tides, which have washed the Earth's shores for billions of years, and which some believe helped coax life from the sea onto the land. And, quietly and crucially, the Moon steadies the Earth. Its gravity holds our planet's tilt gentle and stable, keeping our seasons mild and regular rather than wild and lurching. Without the Moon, the Earth might wobble chaotically, and the whole story of life might have been harsher or impossible. So the most violent day in the Earth's history gave us one of the quiet foundations of a living world. The catastrophe that nearly destroyed the young planet left it with a companion that would calm its spin, gentle its seasons, pull its tides, and light its nights for the next 4.5 billion years. It is a pattern we have seen again and again in these stories, that creation and destruction are so often the same event, seen from two sides. The Earth was shattered, and in the shattering, gained the Moon. There is something worth holding on to in that, drifting here in the dark. The same moon that will rise over your window tonight, so serene and familiar, was born in the single most violent moment our world has ever known, forged from the wreckage of a planetary collision 4.5 billion years ago. It has been up there, circling and steadying and slowly drifting ever since. Every calm, moonlit night you have ever known traces back to that ancient catastrophe. So let the young Earth and its new moon settle in your mind, the wounded, cooling planet, and the bright companion assembling in the sky above it, both of them fresh from the fire. The worst violence is past now. The earth will begin, at last, to cool in earnest, and something extraordinary will gather on its surface: water. In the next chapter, the first oceans come to the world. For now, breathe slowly and rest beneath the newborn moon. After the fire and the great collision, the earth began at last to cool. And as it cooled, it gained the single feature that would make it unlike any other world we know. The feature that shows in every photograph of our planet from space, the thing that makes it not a gray rock, but a blue jewel: water. The oceans came to the earth, and with them, the world of fire quietly became a world of water. To understand where the oceans came from, picture the young, cooling planet wrapped in a thick, hot atmosphere, a dense shroud of steam and volcanic gases belched out from the molten interior through countless volcanoes, and perhaps added to by icy comets and asteroids falling from space. Among all that vapor was a great deal of water, held as steam because the surface was still far too hot for it to be anything else. The early Earth had its oceans already, but they were hanging in the sky as scalding cloud, waiting for the world to cool enough to let them fall. And cool it did. Slowly, over a long age, the surface temperature dropped degree by degree until at last it crossed the threshold where water vapor could become liquid. And then it began to rain. Not a passing shower, but a rain beyond anything the world has known since. A torrential, global downpour that may have lasted for centuries or far longer as the whole steaming atmosphere gradually condensed and fell. The water poured down and gathered in the low places of the cooling crust and rose and spread until the earth had oceans, real, liquid, world-spanning seas. The blue planet was born. We used to imagine this happened late, that the earth stayed a dry hell for a very long time, but those ancient zircon crystals from Western Australia, the oldest bits of the earth we have, hint at something remarkable. That liquid water may have existed on the surface astonishingly early, within just a couple of 100 million years of the planet's birth. The oceans, it seems, came quickly, geologically speaking. The world was in a hurry to be blue, and once the oceans arrived, they never truly left. In one form or another, water has covered most of the earth ever since, for more than 4 billion years. It is worth pausing on how strange and precious this is. Water is common enough in the universe as ice or vapor, but a world with vast, stable, liquid oceans on its surface, staying liquid for billions of years, is something we have found nowhere else, for certain, in all our searching. It requires a planet at just the right distance from its star, not so hot the water boils away, not so cold it all freezes, in the narrow, gentle band we sometimes call habitable. The Earth sat squarely in that band, and kept its oceans, and that single fact would make all the difference. For water is where everything else in this story begins. And the early oceans were not quiet. They were warm and dark and restless, pulled by the tides of the close, looming moon, stirred by fierce storms under a sky still hazy with volcanic gas, lapping at the shores of the first small patches of dark rock that were beginning to poke above the waves. There was no life in them yet, as far as we know. There were no fish, no seaweed, no coral, only warm, mineral-rich, lifeless water, covering nearly the whole face of a young and simmering world. But everything that would ever live was about to begin, down in that dark, warm water. For this is the deep truth of the oceans, and the reason they matter so much to our story. The sea is the cradle. Everything alive on Earth, in the end, came out of the water. The first life would stir in these early seas. Life would spend most of its whole history in the ocean before ever venturing onto the land. And even now, every living cell carries a little of the sea inside it, in the salt of your own blood and tears. The oceans that gathered on the cooling Earth were not just a feature of the planet, they were the womb of everything to come. So picture the young blue world now, its long rains finally easing, its first warm seas spreading dark and restless under a hazy sky and a great close moon. The fire is banked, The water has come. The stage is set. In the next chapter, in the warm dark of those first oceans, the most extraordinary thing in the whole story of the earth quietly begins. Something starts to live. For now, breathe slowly and rest beside the first seas of the world. Somewhere in the warm, dark water of the early earth, something happened that we still do not fully understand, and that may be the most important event in the whole history of the world. A collection of chemicals, drifting and combining in the young sea, crossed an invisible line and began to live. It began to take in energy, to grow, to copy itself. Life started. And once it started, it never stopped. We do not know exactly where or exactly how. Some think it began in warm, shallow pools at the edge of the sea. Many now suspect it began deep down, in the dark, around the hot, mineral-rich vents on the ocean floor, where the chemistry of the earth itself could power the first living things. We do not even know exactly when, but we know it was astonishingly early. The oldest traces of life reach back at least 3.5 billion years, and perhaps closer to 4, which means life appeared on Earth almost as soon as the planet had cooled enough to allow it. The world was barely ready, and life was already here. On this planet, at least, life seems to have been not a rare accident, but an eager one, arriving the moment it could. The first living things were tiny, simple, and single-celled. Microbes, far too small to see, drifting and multiplying in the early ocean. There were no plants, no animals, nothing you could have watched with the naked eye. For an almost unimaginably long time, for most of the entire history of life, in fact, this is all there was, a world of microbes, an invisible living film spread through the seas and across the wet rock, quietly transforming the planet from within. We think of life's story as the story of animals and plants, but those are latecomers. For billions of years, life on Earth was microbial and nothing more. And yet, those microbes left us something we can see, the oldest fossils on Earth. In shallow, ancient waters, certain microbes lived in vast mats, layer upon layer, and as sediment settled over them, they built up, over generations, into low, rounded mounds of finely layered rock. We call them stromatolites, and they are, in effect, fossilized cities of microbes, some of them billions of years old. Remarkably, they are not entirely a thing of the past. In a few salty corners of the world, living stromatolites still grow today, exactly as they did billions of years ago, a living window onto the oldest life there is. To stand before one is to look at the handiwork of the planet's very first inhabitants. It is worth sitting with how patient this all was. Life began early, and then, for a very long time, it stayed simple. It did not rush toward complexity. For well over 1 billion years, life was content to be microbial, drifting and dividing and slowly spreading, changing the world in quiet chemical ways, but never growing large or elaborate. If you had visited the Earth through most of this vast stretch, you would have found a planet that looked lifeless. Blue oceans, bare rock, hazy sky, with all its life hidden in the water and the film on the stones, invisible and immense. The great drama of animals and forests was still billions of years away. But those invisible microbes were not idle. Quietly, cell by cell, over the ages, they were remaking the planet, pulling chemicals from the sea and the air, laying down rock, and in time, beginning to produce a strange and dangerous new gas that would one day transform the entire world and nearly end life altogether. That gas was oxygen, and its story is one of the strangest in all the Earth's history. A tale of how life, in simply going about its business, poisoned its own world, and in doing so, made everything that came after possible. For now, though, rest in the quiet of the early living world, the warm, dark seas, the invisible microbes drifting and multiplying, the first stromatolites rising in the shallows, life newly begun and in no hurry at all. It had all the time in the world, and it took it. In the next chapter, that patient microbial life will change the very air of the planet in the great crisis we call the Great Oxidation. For now, breathe slowly and rest in the first quiet age of life. One of the most dramatic events in the whole history of the Earth was caused not by an asteroid or a volcano or the movement of continents, but by life itself, quietly poisoning its own planet. It is the story of how the air we breathe came to be, and it began with a small microbe that learned a new trick: how to catch the sunlight. For the first stretch of life's history, the tiny microbes of the sea fed on the chemistry around them as best they could. But at some point, certain microbes, the cyanobacteria, sometimes called blue-green algae, hit upon something revolutionary: photosynthesis. They learned to use the energy of sunlight to build their own food, drawing on water and the carbon in the air. It was an enormous advantage, an endless supply of energy pouring down from the sky, free for the taking. The cyanobacteria flourished, spreading through the sunlit surface of the seas. But photosynthesis had a byproduct, a waste gas the microbes simply released and discarded. That waste gas was oxygen. We think of oxygen as the very breath of life, and for us, it is. But to the life of the early Earth, oxygen was something else entirely: a poison. The microbes of that ancient world had evolved in a world without it, and to most of them, this reactive new gas was corrosive and deadly. And now, across the whole planet, the cyanobacteria were pumping it out, relentlessly, as the mere exhaust of their sunlit feasting. For a long time, the world absorbed it. The oceans were full of dissolved iron, and the oxygen bound to that iron and rusted it, pulling it out of the water to settle on the seafloor in vast, striped layers of reddish rock, the banded iron formations, which record this slow rusting of the world, and which are, to this day, the source of most of the iron that humans mine. But the oceans could only rust for so long. Eventually the iron ran out, and the oxygen had nowhere left to go but up, into the air. And so, around 2.5 billion years ago, oxygen finally began to build up in the atmosphere of the Earth, an event so significant that geologists call it, simply, the Great Oxidation. The very composition of the sky changed. For the first time, the Earth had an atmosphere with free oxygen in it, the first faint beginning of the air you are breathing right now. For the life of the time, this was a catastrophe. The rising oxygen was toxic to the vast microbial world that had evolved without it, and it is thought to have caused a great dying, one of the largest extinctions in the planet's history, though it happened among creatures too small to leave much trace. Life, in the simple act of making a living, had transformed the atmosphere and poisoned most of the living world. It is the oldest pollution crisis there is, and the most complete. An entire planet's air changed by the waste of its own inhabitants. There is a strange and sobering echo in it, for a species that is now, in its own way, changing the composition of the very same sky. And yet, as so often in this story, catastrophe was also creation. For that poisonous new gas, oxygen, is also extraordinarily rich in energy. Once life learned not just to tolerate it, but to use it, to breathe it, to burn its food with it, a whole new level of living became possible, far more energetic than anything before. Every animal that has ever lived, including you, runs on the energy of oxygen. The gas that poisoned the ancient world became the fuel of everything that came after. The Great Oxidation was a mass extinction and the foundation of complex life, both at once. So the air itself, the invisible ocean you breathe without a thought, is not a given feature of the planet. It is a thing that life made, built up molecule by molecule over hundreds of millions of years by countless tiny microbes catching the sunlight in the ancient seas. Every breath you take tonight is a gift from those cyanobacteria, billions of years dead. The sky is their legacy. So rest in that quiet marvel, the ancient seas rusting red, the sky slowly filling with a strange new gas, life remaking the whole planet from within, without ever meaning to. In the next chapter, the world settles into a long, slow, patient middle age, and complex life quietly takes its first steps. For now, breathe slowly. Breathe the air the microbes made, and drift. After the great drama of the oxygen crisis, the Earth settled into one of the longest and quietest stretches of its whole history, an age so stable, so seemingly uneventful, that geologists have given it a half-joking name, the boring billion. For roughly 1 billion years, from around 1.5 billion to somewhere past 1 billion years ago, the world seems to have simply idled. The continents quiet, the climate steady, the chemistry of the oceans holding roughly constant, and life changing only very slowly. It is the long, calm middle of the story of the Earth, and it is a lovely thing to rest in, this vast, unhurried plateau of time. But boring is not quite fair, and the quiet was deceptive, for beneath that stable surface, life was taking one of the most important steps it would ever take. Until this point, all life had been made of the simplest kind of cell, tiny and without any internal structure, the bare minimum for living. But somewhere in this long Middle Age, a new and far more complex kind of cell arose, the kind that you and every plant and animal and mushroom are built from. These cells were larger, and they had an inner architecture, a nucleus holding their genetic instructions, and tiny internal engines for turning oxygen into energy. Those little internal engines have a wonderful origin story of their own. They appear to have once been free-living microbes in their own right, small bacteria that were swallowed by a larger cell and, instead of being digested, stayed on, sheltered inside, doing the work of turning oxygen into usable energy. Over time, the two became one. The swallowed became a permanent part of the swallower. Every complex cell in your body still carries the descendants of those ancient captured microbes, humming away, powering you. Life advanced not only by competing, but by joining together, one creature taking another inside itself, and the two becoming something new. Cooperation, written into the very cells we are made of. And in this long, quiet age, life also began, tentatively, to become many-celled. For billions of years, life had been strictly single, every organism a lone cell, going it alone. But now, some of those complex new cells began to stick together, to cooperate, to live as groups that acted as one. It was slow and modest at first, nothing you would call a plant or an animal yet, just simple colonies and filaments and mats. But it was the beginning of multicellular life, the beginning of the road that leads, eventually, to seaweeds and trees and jellyfish and you. The idea of a body, of many cells living and working as a single creature, was being invented, quietly, in the calm of the boring billion. So the great stillness was not emptiness, it was gestation. Beneath a placid, unchanging surface, life was quietly assembling the tools it would need for everything that came after. The complex cell, the partnership of oxygen-burning engines, the first experiments in living together as one body. The stage was being set, slowly, patiently, over a span of time so vast it defies feeling, for the explosion of complex life that was still to come. Sometimes the most important work is done in the quiet, out of sight, with no drama at all. There is a gentle lesson in the boring billion drifting here in the dark. We tend to think that important things must be loud and fast and eventful. But the Earth spent one of its most consequential ages doing almost nothing visible at all, just holding steady, century after century, eon after eon, while life slowly, invisibly, prepared itself. Not every important stretch of time looks important from the outside. Some of the deepest changes happen in stillness. So let yourself rest in the long, calm middle of the world, the quiet continents, the steady seas, the unhurried sky, and hidden within it, life patiently building the foundations of everything to come. There is no drama here to disturb you, only the vast, slow patience of the earth in its middle age. In the next chapter, that long calm ends dramatically as the entire planet freezes over from pole to pole, the astonishing age of snowball Earth. For now, breathe slowly and rest in the quiet billion years. The long calm of the boring billion ended in one of the most extreme episodes the Earth has ever known, a time when the whole planet, it seems, froze over. Not just the poles, not just the far north and south, the entire world, from pole to pole, wrapped in ice, even at the equator, a white planet, a frozen ball drifting through space. Scientists call it Snowball Earth, and though the details are still debated, the evidence that our warm blue world once turned entirely to ice is one of the great surprises of geology. It happened somewhere around 700 million years ago, as the long Middle Age gave way to a more turbulent time. And it seems to have been a runaway. The Earth's temperature is held in balance by many things: the warmth of the sun, the greenhouse gases in the air, the reflectiveness of the surface. And ice is very reflective. It bounces sunlight back into space. So once ice began to spread, it cooled the world further, which let the ice spread more, which cooled the world further still. A vicious cycle, tipping past a point of no return, until the ice sheets marched all the way down from the poles to the tropics and met at the equator. The oceans froze over. The world went white. Picture that Earth, drifting here in your mind, a planet of ice, gleaming pale in the sunlight, its oceans locked beneath frozen crust, its continents buried under glaciers, the whole familiar blue world turned to a silent white ball. It may have stayed that way for millions of years, a deep, planet-wide winter longer than the entire history of humankind, many times over. For life, clinging on in the few refuges where liquid water remained, perhaps around volcanic vents or in cracks in the ice, it must have been the hardest of all times, a bottleneck of cold that only the hardiest survived. And yet the Earth did not stay frozen forever, and the way it thawed is as dramatic as the way it froze. Even on a snowball planet, the volcanoes kept erupting, and they kept breathing out carbon dioxide, a greenhouse gas, into the air. With the oceans frozen, there was little to absorb it, and so, over millions of years, it built up and built up in the atmosphere, thickening, trapping heat, until at last, the greenhouse warming overwhelmed the reflective ice, and the balance tipped the other way, and the great thaw began, running away just as the freeze had, the ice retreating, the dark oceans opening to the sun, the white world turning blue again in a geological instant. And here's the extraordinary thing, the part that ties this frozen chapter to everything that follows. It was almost immediately after the Earth thawed from its snowball state that complex animal life exploded onto the scene. The two events sit side by side in the rocks, the Great Freeze, and then, hard upon its heels, the sudden flourishing of large, complex living things. We do not fully understand the connection. Perhaps the extreme stress of the freeze and thaw drove life to new forms. Perhaps the thaw flooded the oceans with nutrients scraped from the land by the glaciers. Perhaps the rising oxygen finally reached the level complex animals needed. But the timing is striking. The world froze nearly to death, and then, thawing, burst into its richest life. There is a strange comfort in it, resting here in the dark. The Earth has been through extremes we can barely imagine, has been a ball of fire and a ball of ice, and survived them both, and come back each time to blue and living. Our world is more resilient and more changeable than its calm blue face suggests. It has frozen solid and thawed again and gone on. Whatever the Earth is now, it has been many other things and endured. So picture the great thaw, the white planet slowly warming, the ice cracking and retreating, the dark seas opening once more to the sun, and life, battered, reduced, but unbroken, stirring again in the warming water, on the edge of its greatest flowering. In the next chapter, we arrive at that flowering, the Cambrian explosion, when the seas suddenly fill, in the blink of a geological eye, with complex animals, with eyes and shells, and the first great drama of predator and prey. For now, breathe slowly and rest as the frozen world turns gently back to blue. For more than 3 billion years, for most of the entire history of life, the living world had stayed small and simple. Microbes, then complex cells, then the first tentative multicellular things drifting quietly in the seas. And then, around 540 million years ago, in a stretch of time that is barely an eye blink by the standards of this story, the ocean suddenly filled with complex animals. Almost all at once, in the rocks, there appear creatures with shells, with limbs, with eyes, the ancestors of nearly every kind of animal alive today. We call it the Cambrian explosion, and it is one of the great turning points in the history of the world. It is called an explosion because of how sudden it looks. For billions of years, the fossil record is quiet. Microbes, mats, soft, simple things. And then, over a geologically brief window of a few tens of millions of years, it erupts. Trilobites with segmented armor and complex eyes, strange swimming predators, creatures with spines and shells and grasping limbs, the first representatives of most of the major groups of animals that still exist. The basic body plans of the animal kingdom, the arrangements that would become insects and fish and starfish and, eventually, us, nearly all trace their origins to this remarkable flowering. It is as if, after 3 billion years of patience, life suddenly discovered how to be complicated all at once. Scientists still work to understand exactly how and why it happened so fast. The researcher Douglas Irwin and his colleagues have called it the Cambrian conundrum, this puzzle of a sudden burst after so long a stillness. Part of the answer is surely the rising oxygen, finally reaching levels that could fuel large, active animal bodies. Part of it may be the aftermath of the great snowball freeze, which cleared the stage and stirred the waters. And part of it, once it began, was life driving itself onward. Because once some creatures grew complex, they changed the world for all the others and set off a race. For the Cambrian saw the invention of something that changed everything: predators. For the first time, some animals began to hunt and eat other animals, and that single innovation transformed the living world into an arms race. If some creatures could hunt, others needed to defend themselves, and so came shells and armor and spines and burrows and speed. And to hunt or to flee, it helped enormously to see, and so, in the Cambrian, animals evolved the first true eyes, complex eyes that could form images, opening up a whole new way of experiencing the world. Predator and prey, shell and eye, hunter and hunted, the great drama of animal life, which is still playing out in every ocean and forest today, began here in the Cambrian seas. We have extraordinary windows onto that vanished world, where the soft bodies of Cambrian creatures were, by rare luck, preserved in fine detail in stone. And what they show is a sea both familiar and deeply strange, swarming with trilobites, patrolled by large swimming predators with grasping arms and rings of teeth, dotted with creatures so odd that scientists at first could hardly tell which end was the head. It was a world of experiment, life trying out body plans with wild abandon, some of which endured and some of which vanished forever, leaving no descendants. Strange dead ends of the animal kingdom, tried once and never again. There is something wonderful in picturing it. The shallow Cambrian seas, 500 million years ago, suddenly crowded with the first complex animals. Armored trilobites trundling across the seafloor, the first predators cruising above, the first eyes turning to watch the first prey, in warm, ancient water under a sky that had never seen a bird or a cloud of pollen. This is the deep root of the whole animal kingdom, the moment life stopped being simple and became the teeming, various, dramatic thing we know. Every animal you have ever seen is a distant cousin of those Cambrian creatures. So rest in the Cambrian seas, in the great flowering of animal life, the ancient waters newly alive with shells and limbs and watching eyes, the long stillness finally broken. Life had learned to be complex, and it would never look back. In the next chapter, life takes an even bolder step. It crawls out of the water entirely and begins, for the very first time, to colonize the bare and empty land. For now, breathe slowly and drift among the first animals of the world. For more than 4 billion years, the land of the earth was bare. Picture it, the seas teeming with the new life of the Cambrian and after, trilobites, fish, all the busy drama of the animal kingdom. And beyond the shoreline, nothing. The continents were rock and sand and stone, gray and lifeless, swept by wind and rain, without a blade of grass, without a leaf, without a single living thing moving across them. For almost the whole history of the planet, life belonged entirely to the water. The land was an empty country, waiting. The first pioneers onto that empty land were, as they so often are, the small and the humble. Simple plants, the ancestors of mosses, low and creeping, clinging to the damp edges of the water, began, around 470 million years ago, to spread onto the wet margins of the land. It was a hard place to live. There was no soil, only bare rock. The sun beat down without the shelter of shade, and out of the water, a living thing had to hold itself up and keep from drying out, with none of the support the sea had always given. But life is persistent, and slowly, over millions of years, the plants took hold. First low and small, then taller, learning to stand, to draw water up from the ground, to spread and green the edges of the world. And as the plants spread, they changed the land itself, making it ready for everything to follow. Their roots and their remains broke down the bare rock and mixed with it, and so, for the first time, the earth grew soil, that living skin of broken stone and decayed life that covers the fertile land today, and that had simply never existed before. The plants also breathed out oxygen and drew in carbon, tugging at the planet's climate. The greening of the land was not just life arriving on the continents, it was life building the continents into a place where more life could live. The plants made the world habitable for what came next. And what came next followed the plants out of the water. Where there are plants, there is food and shelter, and so the animals came ashore. The first were small, the ancestors of insects and spiders and millipedes, little armored creatures that could seal themselves against drying out and scuttle across the new green land. For a long time, the land belonged to these small invertebrates and the low forests they lived in. But in time, something larger hauled itself out of the shallows, the fish that were becoming something new. For in the rivers and swamps, certain fish had been developing sturdy, fleshy fins and the ability to gulp air. Over millions of years, in the shrinking pools and muddy margins, those fins became limbs, and those air-gulping fish became the first four-legged animals, the tetrapods, dragging themselves up onto the land around 375 million years ago. They were the ancestors of every amphibian, reptile, bird, and mammal that would ever live, including you. The bones in your own arm, one bone, then two, then the many small bones of the wrist and hand, are the same pattern, inherited and reshaped, as the fins of those first fish that crawled ashore. You carry the architecture of that ancient crawl in your own body. It is worth pausing on the strangeness and the courage of it. Life leaving the sea, its home for billions of years, for the harsh, dry emptiness of the land. Everything about the water was familiar and supporting. Everything about the land was hostile and new. And yet life went, as it always seems to go, into the difficult new frontier. Plants first, then the small crawlers, then the first four-legged pioneers. And in going, it opened up a whole new world. The bare gray continents began, at last, to turn green and to stir with movement, and the empty land became a living land. So picture the ancient shore, 370 million years ago. The water's edge fringed now with green, low plants creeping up from the damp, small creatures scuttling among them, and a strange, blunt-headed creature with four stubby limbs hauling itself, dripping, out of the shallows onto the muddy bank, into the sunlight and the air. The land was being claimed. In the next chapter, that green will grow into the first great forests, the vast, swampy jungles whose buried remains we still burn today. For now, breathe slowly and rest on the newly living shore. Once life had taken to the land, the plants did something they had never done before. They grew tall. And around 360 million years ago, the earth entered an age of forests unlike anything before or since. Vast, steamy, swampy jungles that blanketed the low, wet continents in green. We call this time the Carboniferous, and its name, meaning coal-bearing, holds a secret. Those ancient forests are still with us today, buried deep as the coal we dig from the ground. This is the age that, in a very real sense, we have been burning. Picture the Carboniferous world. Great lowland swamps stretched for endless miles, warm and wet and humid, choked with towering plants, but not the trees you know. These were giant relatives of today's humble mosses and ferns and horsetails, grown monstrous. Club mosses as tall as buildings, with strange, scaly trunks. Tree ferns arching overhead, horsetails thick as pillars. It was a green cathedral of a world, dim and dripping and dense, its still black waters reflecting a canopy of alien plants, the air thick and heavy and warm. There were no flowers yet, and no grass, just endless towering green, and the slow drip of water in the gloom. And the air of that world held a strange and wonderful property. It was extraordinarily rich in oxygen. All those vast forests, breathing out oxygen through their endless leaves, drove the level in the atmosphere far higher than it is today. And high oxygen allowed animals to grow to sizes that would be impossible now, especially the insects and their kin, whose way of breathing limits how large they can become. In the oxygen-rich carboniferous air, they grew into giants. Dragonflies with wings as wide as a hawk's, cruising through the humid canopy. Millipedes longer than a person, trundling across the forest floor. Spiders and scorpions and cockroaches on a scale that would be the stuff of nightmares today. It was, quite literally, an age of giant bugs, made possible by the richness of the air. And through this green world moved the descendants of those first four-legged pioneers. The early amphibians, still tied to the water to breed, sprawling through the swamps. And, importantly, the very first reptiles, who had made a crucial breakthrough. They had evolved an egg with a shell, an egg that could be laid on dry land without drying out, which meant that, for the first time, animals could break their ancient tie to the water and move inland, into the drier country beyond the swamps. It was a quiet revolution. Life no longer needed to return to the water to reproduce. The reptiles would carry that freedom far, in time giving rise to the dinosaurs, the birds, and the ancestors of the mammals. But the deepest legacy of the Carboniferous is the coal. In those vast swamps, generation after generation of giant plants grew and died and fell into the still, waterlogged ground, where, starved of oxygen, they did not fully rot away. Instead, they piled up, layer upon layer, and were buried and pressed and slowly, over hundreds of millions of years, transformed by heat and pressure into thick seams of coal. All the energy those forests had captured from the Carboniferous sun was locked away underground and held there, patiently, for 300 million years, until we came along and dug it up and burned it, releasing that ancient sunlight and the ancient carbon with it into our modern sky. The forests of the Carboniferous are the coal that built the modern world, and their buried carbon is now returning to the air, with consequences we are only beginning to reckon with. There is a long, quiet thread here worth resting on. The oxygen you breathe was made by ancient microbes, and the coal that powered the factories and the trains and the power stations of the last 2 centuries was made by ancient forests 300 million years ago, capturing sunlight in a steamy green world of giant ferns and dragonflies. We are more deeply woven into the deep history of the Earth than we ever normally feel. Even our machines run, in the end, on the buried sunlight of the Carboniferous. So picture that vast, warm, green swamp world drifting here in the dark. The towering club mosses, the giant dragonflies gliding through the humid air, the still black water, the endless dripping green under a heavy sky. It is one of the strangest and most beautiful ages the Earth has ever worn. In the next chapter, this lush world and nearly everything alive will come to the edge of total annihilation in the worst catastrophe life has ever faced, the Great Dying. For now, breathe slowly and rest in the green cathedral of the ancient forests. Around 252 million years ago, life on Earth came closer to ending than at any other time in its long history. It was not an asteroid this time, and not a snowball freeze. It was, most likely, the Earth itself, its own deep fires that nearly extinguished all life. Geologists call it the end Permian extinction, but it has a plainer and more fitting name, the Great Dying. It was the worst catastrophe life has ever faced, and life barely survived it. The numbers are almost hard to speak. In the seas, something like 9 out of every 10 species vanished, perhaps more. On land, the great majority of animal life was wiped out too. Whole groups of creatures that had thrived for hundreds of millions of years, including most of the trilobites, those ancient armored survivors of the Cambrian seas, were gone forever. Life had weathered hard times before, but never anything like this. The living world was reduced to a scattered remnant, a bare skeleton of what it had been. For a while, the Earth was nearly emptied of complex life. It came within a hair of being reset almost to the beginning. What caused it? The leading answer lies in Siberia, in an outpouring of volcanic fire on a scale we can barely picture. Over a stretch of this time, in what is now Siberia, the Earth's crust cracked open and erupted. Not a single volcano, but vast floods of lava welling up across an area the size of a continent, again and again, for a very long time. These eruptions, called the Siberian Traps, are among the largest volcanic events in the history of the planet. And it was not the lava itself that did the killing, but what it breathed into the sky. For those eruptions poured enormous quantities of carbon dioxide and other gases into the atmosphere, and the world responded as a world does. The climate warmed, sharply and severely. The oceans grew hot and acidic and starved of oxygen, until vast stretches of the sea became dead zones where almost nothing could live. On land, the warming and the poisoned air did their work too. It was a cascade, volcanism driving warming, warming driving the collapse of the oceans and the land alike, each catastrophe feeding the next, until the living world simply gave way. Life was not so much killed as suffocated, cooked, and starved all at once over a span that was brief by geological standards, but endless by any other. There is a sobering echo in it, and it would be dishonest not to name it gently. The Great Dying was, at its root, a carbon crisis, a sudden flood of carbon dioxide into the air from the Earth's own fires, warming the world and wrecking the seas. We are now, in our own brief moment, releasing carbon into that same sky from the burning of those ancient carboniferous forests, faster in some respects than even the Siberian traps managed. The Earth has shown us, in its own deep past, what a great pulse of carbon can do to a living world. It is worth listening to. And yet, as always in this story, life did not end. Reduced to a fraction of itself, battered almost beyond recognition, life held on, in scattered refuges, and slowly, over millions of years, it recovered. It always recovers. The seas refilled with new forms, the land grew green again, and from the survivors of the Great Dying, whole new dynasties would arise. Indeed, the emptying of the world made room for something new. Among the survivors were the ancestors of a group that would rise, in the recovering world, to a dominance the Earth had never seen: the dinosaurs. The greatest catastrophe in the history of life cleared the stage for its most famous age. So rest with the Great Dying, but do not fear it, for it is, in the end, a story of survival as much as of death. The Earth was pushed to the very edge, and life clung on, and came back, and flourished again, as it has after every catastrophe in this long tale. Our world is a survivor, many times over. In the next chapter, we will watch the very continents themselves drift and gather in the slow dance of the restless crust, and meet the great supercontinent, Pangaea. For now, breathe slowly, and rest in the quiet after the great storm of the Great Dying, as life gathers itself once more. We tend to think of the map of the world as fixed, the shapes of the continents so familiar we could draw them from memory, as permanent as anything could be. But they are not permanent at all. The continents are moving, right now beneath your feet, drifting across the face of the Earth as slowly and surely as they have for billions of years. The map of the world is only a single frame of a film that has been running since the planet was young. And around the time of the Great Dying, that slow drift had gathered nearly all the world's land into a single vast supercontinent, which we call Pangaea. The engine of this movement is one of the great discoveries of the last century: plate tectonics. The Earth's hard outer shell is not a single unbroken skin, but a set of enormous, rigid plates, like the cracked shell of an egg, floating on the hot, slowly churning rock of the mantle below. And those plates are in motion, carried along on the deep currents of the Earth's interior at about the speed your fingernails grow, a few centimeters a year. It is imperceptibly slow to us, but over the vast reaches of geological time, a few centimeters a year is enough to carry a continent clear across the world, to split one landmass in two, or to drive two together in a slow-motion collision that crumples the crust upward into mountain ranges. For the mountains, too, are made this way. Where two plates collide, the crust has nowhere to go but up, buckling and folding over millions of years into great ranges. The Himalayas, the highest mountains on Earth, are still rising today, pushed up by the slow crash of India into the rest of Asia, a collision still underway. And where plates pull apart, new ocean floor is born, welling up from below. And where one plate dives beneath another, it plunges back down into the Earth, feeding volcanoes and carving the deep ocean trenches. The whole restless surface of the planet, its mountains, its oceans, its earthquakes and volcanoes, is the work of these great, slow-moving plates. By around the time of the Great Dying and after, this drifting had assembled almost all the Earth's land into one, Pangaea, a single enormous supercontinent, stretching from pole to pole, surrounded by one vast world ocean. Imagine standing on it, a landmass so huge that its deep interior lay thousands of miles from any coast, a parched and continental heart far from the softening reach of the sea, with harsh extremes of heat and cold. It was a strange world to have only one great continent and one great ocean. And it was, of course, temporary, as everything on the drifting earth is temporary. For Pangaea, having gathered, then began to break apart. Great rifts opened across it, the land tore along the seams, and slowly, over the next 200 million years, the pieces drifted away from one another to become the continents we know. The Atlantic Ocean was born as the Americas pulled away from Europe and Africa, and it is still widening today, a few centimeters a year, so that New York and London drift a little farther apart with every passing year. The familiar map of our world is simply the shattered pieces of Pangaea, still slowly moving, and in the deep future, they will gather again into some new supercontinent we will never see. There is something wonderfully humbling in this, resting here in the dark. The solid ground, the very definition of stillness and permanence in our lives, is not still at all. It is drifting, endlessly, in slow, grand currents, gathering and scattering the continents over and over across the ages. The land beneath you has been on the far side of the world and will be again. It has been the floor of an ocean and the heart of a supercontinent and the peak of a mountain range long since worn away. Nothing about the earth holds still if you wait long enough, not even the ground. So let the slow dance of the continents settle your mind, the great plates drifting, gathering into Pangaea, tearing apart again, the map of the world endlessly, imperceptibly reshaping itself beneath the feet of everything that lives. It is the slowest movement you will ever be part of, and you are riding on it right now. In the next chapter, upon these drifting continents, the most famous creatures in all of Earth's history rise to rule, the dinosaurs. For now, breathe slowly and drift with the continents in the dark. Out of the wreckage of the Great Dying, on the drifting land of Pangaea and the continents it became, there arose the most famous creatures ever to walk the earth, the dinosaurs. For an almost unimaginable stretch of time, some 165 million years, they ruled the land, in every size and shape, the undisputed masters of the world. We are so used to them as figures of legend in museum halls that it is easy to forget they were real animals, who lived and bred and died on this same earth, under this same sun, for a reign far, far longer than our own kind has yet managed. They arose modestly, as most great dynasties do. In the recovering world after the Great Dying, in the period we call the Triassic, the early dinosaurs were small and unremarkable, just one group among many trying to make a living in a hard, hot, recovering world. But they had their advantages, and over millions of years they grew larger, more varied, more dominant, until they had spread into nearly every role on land. By the periods we call the Jurassic and the Cretaceous, the age of dinosaurs was in full flower, and the earth belonged to them. And what a range of creatures they were! There were the giants, the long-necked sauropods, the largest animals ever to walk on land, so enormous that the ground itself must have trembled at their passing, browsing the treetops like living cranes of flesh and bone. There were the great predators, walking on two legs, with jaws built for hunting. There were armored dinosaurs plated and spiked like living tanks, horned dinosaurs with great bony frills, crested dinosaurs that may have called to one another across the plains. They lived in herds and hunted in the forests and nested in colonies. For over 100 million years, in endless forms, they filled the living world. But the dinosaurs were not alone, and two quiet presences in their shadow matter enormously to our story. The first is the birds. For the birds are not merely the descendants of dinosaurs. In a real sense, they are dinosaurs, the one branch of that great family that survives to this day. Feathers, it turns out, arose among the dinosaurs, and some small feathered dinosaurs took to the air and became the birds. Every sparrow at your window, every gull over the sea is a living dinosaur, the distant echo of that vanished age singing in your garden. The dinosaurs never fully died. They fly around us still. The second quiet presence is us, or rather, our distant ancestors. For all through the long age of dinosaurs, there also lived the first mammals. Small, furry, mostly nocturnal creatures, no bigger than mice or shrews, scurrying in the undergrowth and the dark, keeping out of the way of the giants that ruled the day. For over 100 million years, our ancestors lived like this, tiny, timid, marginal, in the shadow of the dinosaurs, waiting, though they did not know they were waiting, for their moment. The mammals were the understudies of the Mesozoic, and they would get their chance only when the dinosaurs' reign came to its sudden, catastrophic end. It is worth pausing on the sheer duration of the dinosaurs' rule, because it puts our own brief moment in its place. They dominated the Earth for over 160 million years. Our own species has existed for perhaps 300,000, a tiny fraction of that. If the dinosaurs' reign were a single day, all of human history so far would be the last couple of minutes before midnight. They were not a footnote or a prelude to us. They were the overwhelming main body of the story of land animals, a reign so long it dwarfs everything that came after. We are the newcomers, living in a world the dinosaurs shaped and ruled for an eternity before we arrived. So picture that long green age drifting here in the dark, the giant long-necked sauropods moving slowly through the ferns, the herds crossing the plains, the small feathered forms flitting through the trees, and, hidden in the leaf litter, the tiny furred ancestors of every mammal, watching with bright eyes from the dark. It was the Earth's longest and most magnificent age of giants, but it was about to end in a single terrible day. In the next chapter, the sky falls. For now, breathe slowly and rest in the long reign of the dinosaurs. 66 million years ago, on an ordinary day, the reign of the dinosaurs, a reign of 165 million years, ended in a matter of hours. It ended because something fell out of the sky. And the story of how we came to know this is one of the great detective stories of science, hidden all along in a thin layer of clay. In the 1970s, a geologist named Walter Alvarez, working with his father, the physicist Luis Alvarez, was puzzling over a strange, thin band of clay found in rocks all over the world. A band that lay exactly at the boundary between the age of dinosaurs and the age that followed, marking the very moment of their disappearance. They decided to measure the chemistry of that clay, and they found something astonishing. The layer was rich in iridium, a metal that is rare in the Earth's crust, but common in asteroids and comets. There was far more of it in that thin worldwide band than there had any right to be. In 1980, the Alvarez team drew the bold conclusion that iridium had come from space. An enormous asteroid had struck the Earth, and its dust, spread around the whole globe, was that thin, deadly layer of clay. The impact site was found later, buried and hidden, a vast crater, well over 100 miles across, centered near the town of Chicxulub on the coast of Mexico. The asteroid that made it is thought to have been perhaps 10 kilometers wide, a mountain of rock falling from the sky. When it struck, it hit with a violence almost impossible to comprehend, an explosion beyond any weapon ever imagined, throwing up a curtain of molten rock and vapor, setting off enormous waves and blasting so much debris into the sky that it fell back to Earth glowing hot, igniting fires across much of the world. But the killing blow was not the impact itself. It was the aftermath, the darkness. So much dust and soot was thrown into the high atmosphere that it spread around the entire planet and blotted out the sun, plunging the whole world into a dim, cold twilight that lasted for months, perhaps years. And in that darkness, the plants could not photosynthesize, and they died. And the animals that ate the plants starved. And the animals that ate those animals starved in turn. The whole living world, from the greatest dinosaur to the smallest creature dependent on the food chain, was pushed into collapse. It is thought that around 3/4 of all species on Earth vanished, and every last one of the great dinosaurs, the giants that had ruled the land for over 100 million years, was gone. And yet, once again, life did not end. Some creatures made it through the long dark, the small, the sheltered, the ones that could scrape by on seeds and scraps and rotting matter when the green world failed. Among the survivors were some of the feathered dinosaurs, the birds, which is why dinosaurs, in that form, are still with us. And among the survivors, too, were those small, furred, unremarkable creatures that had spent the whole long age of dinosaurs hiding in the undergrowth, the mammals. Small size and humble habits, so long a mark of their marginal place in the world, now turned out to be exactly what it took to survive the apocalypse. The meek, quite literally, inherited the earth. There is a staggering contingency in this, worth resting on in the dark. Had that asteroid arrived a little earlier or a little later, it would have missed the Earth entirely, and the dinosaurs might be ruling still, and we, the descendants of those hiding mammals, might never have had our chance. Our entire existence traces back, in part, to the chance arrival of a single rock from space 66 million years ago. The catastrophe that ended one world opened the door to ours. It is the same pattern we have seen again and again, destruction and creation, the same event from two sides, but never more sharply drawn than here. So picture that ancient day, and then let it settle into peace. The great flash on the far horizon, the long dark that followed, the reign of the giants ending, and, unnoticed in the ruins, small furred creatures creeping out into a changed and empty world that was, though they could not know it, about to become theirs. In the next chapter, in the world the dinosaurs left behind, the age of mammals begins, the age that leads at last to us. For now, breathe slowly and rest in the quiet after the sky has fallen. In the strange, quiet, emptied world that followed the fall of the asteroid, with the great dinosaurs gone and the long dark finally lifted, the survivors crept out into a landscape full of empty room. And among those survivors were the mammals, small, furred, and until now marginal, having spent 100 million years hiding in the shadows. Now the shadows were empty of giants. The stage was clear, and the mammals, at last, stepped onto it. The age of mammals, our age, had begun. What followed was one of the great flowerings of life. Freed from the dominance of the dinosaurs, and with countless ways of living suddenly vacant, the mammals diversified with astonishing speed and variety. From those small, generalized survivors came, over the millions of years that followed, nearly every mammal we know. Some grew large, taking over the role of big plant eaters the dinosaurs had left empty. Some became fierce hunters. Some took to the trees. Some, remarkably, went back to the sea and became the whales and dolphins, land mammals that returned to the water their ancestors had crawled out of, and grew into the largest animals the planet has ever known, larger even than the greatest dinosaurs. Others took to the air as bats. The mammals spread into every corner of the world, and the world itself was changing to suit them. As the age of mammals went on, the climate slowly cooled and dried, and a new kind of plant spread across the drying continents, grass. Great grasslands opened up where forests had been, the prairies, the savannas, the steppes, and with them came the mammals of the open plains, the ancestors of horses and antelope and cattle, running herds grazing the new grass, and the predators that chased them. The familiar shape of the modern living world, grazing herds on open plains, hunted by fast predators, was taking form. The earth was becoming recognizable at last, and among the mammals, in the forests, was one modest group whose story we have told elsewhere on another long night: the primates. Small, clever, tree-dwelling creatures with grasping hands and forward-facing eyes and quick, curious minds. For most of the age of mammals, they were just one branch among many, nothing to mark them out as special. But from that branch would come, in the very last chapter of the Earth's long story, the creatures who would one day look back and piece all of this together, who would read the age of the Earth in ancient lead and the asteroid in a layer of clay, and the whole 4.5 billion year story in the rocks. From those quiet primates would come us. But that is nearly the end of the story, and we are not quite there yet. For now, the age of mammals is simply the world settling into the forms we know, a warming and cooling, drying and greening world, filling with the ancestors of the animals we recognize, the whales in the seas, and the herds on the plains, and the primates in the trees. It is the most recent of the Earth's great ages, and the one we are still living in. When you see a deer, or a whale, or a mouse, or your own reflection, you are looking at the age of mammals, the long, slow flowering that followed the fall of the dinosaurs, still going on around you. There is a quiet gratitude worth feeling here, drifting in the dark. We exist because of an emptying, because a catastrophe cleared the world of its rulers and gave our small ancestors their chance. Every mammal alive, from the blue whale to the shrew to you, is a beneficiary of that ancient disaster and the long recovery that followed. We are the children of the survivors, living in the world the dinosaurs left behind, in an age that is still, quietly, unfolding. So rest in the age of mammals, the empty world slowly filling again with life, the grasslands spreading, the herds and the whales and the small, clever primates finding their places, the modern world taking shape at last. In the next chapter, the world grows cold, and the great ice ages come, the frozen ages that shaped the final stretch of the story, right up to the doorstep of our own arrival. For now, breathe slowly and rest in the warm flowering of the mammals' world. As the age of mammals wore on, the earth grew colder. The warm, green, ice-free world of the dinosaurs and the early mammals slowly gave way over tens of millions of years to a cooler planet, until, a few million years ago, the world crossed a threshold and the ice came. Great sheets of it began to gather at the poles and to march down across the northern lands. The earth entered the ice ages, the frozen final stretch of the story, the world that shaped our own ancestors, and the world we, in a sense, still live in the tail of. The cooling had many causes, working over the long haul, drifting continents rearranging the ocean currents, mountains rising and changing the flow of the air, the slow shifting of the planet's chemistry. But once the world was cold enough, a subtler rhythm took over, and it is a beautiful one. The Earth's path around the sun and the tilt and wobble of its axis change in slow, regular cycles over tens of thousands of years, and those cycles gently alter how much sunlight falls on the northern lands each summer. When the summers grow just cool enough that the winter's snow does not fully melt, the ice begins to build. And so, in time with those slow orbital rhythms, the great ice sheets have advanced and retreated over and over in a long, slow pulse of cold and warmth. At the height of an ice age, the world was transformed. Vast ice sheets, kilometers thick, covered much of the northern continents, burying the land where great cities now stand under mountains of ice. So much of the world's water was locked up in ice that the seas drew down, and dry land emerged where there are now shallow seas, joining lands that are now separated. It was a harsher, colder, drier world, and across its cold plains roamed the great beasts of the Ice Age, the woolly mammoths and woolly rhinos, the giant deer, the cave bears, and the saber-toothed cats, all wrapped against the cold. And among them, learning to survive the cold with fire and fur and wit, were our own ancestors. For this is the world in which humans became human. The last stretch of the Ice Ages is exactly the time when our kind arose and spread, and the going and coming of the ice shaped us. The rhythm of freeze and thaw drove the changing of the land, opened and closed the routes our ancestors traveled, and pressed upon them the hard problems of surviving a cold and shifting world. When our ancestors walked out across the earth, they did it across an Ice Age world, along coasts and land bridges that the low seas had opened. The ice was the backdrop of the whole human dawn, and here is something to hold gently. We are, most likely, still in an ice age, merely in one of its warm pauses. The great ice sheets have not gone for good. They have simply retreated, as they have many times before, into one of the warm intervals between the cold ones. We happen to have arisen and built our whole civilization during one of these mild, warm windows, the pleasant, stable stretch of the last several thousand years in which all of farming and cities and recorded history has taken place. By the long rhythm of the ice, the cold might one day return, though now, of course, our own hand on the planet's thermostat has entered the story, and what comes next is no longer only up to the slow cycles of the sky. There is an intimacy to this chapter that the others do not have, drifting here in the dark, for this is the world that made us, close enough to almost touch. The mammoths on the cold plains, the ice sheets grinding south, the low seas and the open land bridges, our own ancestors huddled by their fires against the long winters. This is the doorstep of our own story, the final scene of the Earth's long history before we truly arrive. The whole vast tale, from fire to oceans to oxygen to dinosaurs, has led, at last, to this cold and recent world, with humans stirring in it. So rest in the age of ice, the great white sheets advancing and retreating in their slow rhythm, the shaggy beasts on the frozen plains, the small fire-lit bands of our ancestors surviving the cold. We are almost at the present now. In the next chapter, we arrive at our own strange, brief moment, the human blink of an eye at the very end of the story of the Earth. For now, breathe slowly and rest in the cold, quiet world of the ice. And so, at the very end of this immense story, after 4.5 billion years of fire and ocean, of oxygen and ice, of the rise and fall of countless forms of life, we arrive, at last, at ourselves, humans. We appear in the final sliver of the final chapter, so late in the story that we almost miss it entirely. And the most important thing to understand about our arrival is how staggeringly recent and how staggeringly brief it is. There is a well-worn way of feeling this, and it is worth doing slowly. Imagine the entire history of the Earth, all 4.5 billion years, compressed into a single day, from midnight to midnight. On that scale, the Earth forms at midnight. Life appears in the early morning, and then for hour after hour after hour, all through the day, there is nothing but microbes in the sea. Complex animals do not appear until the evening. The dinosaurs arrive late at night and are gone before midnight. And humans? Our whole species appears in the last few seconds before midnight. All of recorded history, every civilization, every war, every book, every life anyone has ever remembered, is the last fraction of the last second. We are the newest thing on the Earth by an almost incomprehensible margin. We have told the human story in full on another night. The long walk from the African savanna, the fire, the growing mind, the spread across the world. So tonight we touch it only lightly, and only to place it where it belongs, at the very tail end of the Earth's story, a brief, bright flicker at the close of an enormous book. Our kind has existed for perhaps 300,000 years. The Earth has existed for 4.5 billion. We are to the Earth as a single day is to a long human life, and not even the whole day. And yet, this is the strange and double-edged wonder of it. In that last flicker of time, this one late-arriving creature has done something no other has. It has looked back. Of all the countless forms of life across 4.5 billion years, we are the first, as far as we know, to have figured out the story itself, to read the age of the planet in ancient rock, to find the dinosaurs' end in a layer of clay, to trace the drifting of the continents and the rusting of the ancient seas, and to hold the whole vast history of the Earth inside a mind. The Earth, in us, has become able to remember its own past. That is a rare and precious thing, whatever else may be said of us. It is also a humbling place to stand. For all our power, and we have become, astonishingly, a force that shapes the planet itself, changing the very air and climate in ways that echo the great events of the deep past. We are unfathomably new here. The Earth was doing perfectly well without us for 4.5 billion years, through fire and ice and catastrophe, and it will carry on in some form long after us. We are not the point of the story, nor its end. We are its latest and briefest chapter, a chapter that has only just begun and whose ending is not yet written. There is a peace to be found in that smallness, drifting here in the dark. It is easy to feel that everything rests on us, that our moment is the whole of things. But the long story of the Earth gently corrects that. We are a recent, brief, and wondrous part of something almost immeasurably older and larger than ourselves, a story that ran for billions of years before we opened our eyes, and will run on after we close them. To know that is not to feel diminished. It is to feel held within something vast and patient and enduring, of which we are lucky, for a little while, to be a conscious part. So rest in your own late and lucky place in the story, the newest creature on an ancient world, the brief flicker at the end of the long day, the one who came at last to look back and understand. In the next chapter, we return to the planet itself as it is right now in our moment, the restless, living, breathing Earth we are riding through space tonight. For now, breathe slowly and rest in the quiet wonder of how new and how small and how remarkable we are. We have followed the Earth across 4.5 billion years all the way to the present. But it would be a mistake to think the story has stopped, that the Earth, having made us, has settled into stillness. It has not. The planet beneath you tonight is as restless and alive as it has ever been. Its story is not finished. It is simply passing, right now, through the moment we happen to be awake for. Let us rest for a chapter in the living Earth of the present day. Beneath your feet, the great plates are still drifting at their patient fingernail pace, carrying the continents on toward their next configuration. The Atlantic is still widening, the Himalayas are still rising, the Pacific is slowly closing. Every earthquake is the crust adjusting, the plates slipping past one another. Every volcano is the deep heat of the planet finding its way to the surface, exactly as it has since the world was young. The Earth's interior is still hot, still churning with the leftover heat of its fiery birth and the slow decay of elements within. And that inner heat still drives everything on the surface, the drifting and the quaking and the eruptions. The planet is a living engine, and it has not cooled down. It is still going. And wrapped around this restless rock is the thinnest, most precious layer of all, the biosphere, the film of life. Set against the size of the Earth, all of life occupies an astonishingly thin skin. A few kilometers up into the air, a few kilometers down into the sea and the soil, and that is nearly all. If the Earth were the size of an apple, the whole living world, every forest and ocean and creature, all of it, would be thinner than the apple's skin. Everything that has ever lived, the whole 4 billion-year story of life, has played out in that fragile film, clinging to the surface of a vast ball of rock and metal. It is a humbling thing to picture how thin the living layer really is, and that thin film is not separate from the rock and the air and the water. It is woven through them, in great cycles that keep the whole system turning. Carbon moves in a vast, slow loop between the air, the oceans, the living world, and the rock, over timescales from days to hundreds of millions of years, breathed out and drawn in, buried and released. The same carbon, cycling endlessly through everything. Water rises from the sea, falls as rain, runs to the rivers in the living world, and returns. The oxygen, the nitrogen, the very stuff of life, passes round and round. The Earth is not a collection of separate parts, but a single vast interconnected system. Rock and water and air and life, all bound together, all shaping one another in a planet-wide dance that has been running for billions of years. It is into this ancient, balanced, turning system that our own kind has recently stepped and begun, in our brief moment, to alter it. By digging up and burning the buried carbon of those ancient forests, we have begun to shift the great carbon cycle faster than it has moved in a very long time, changing the composition of the air and the balance of the climate. The Earth has known great pulses of carbon before, in the deep past, and we have seen in this very story what they can do. We are, without quite meaning to, running one of the planet's old experiments again. And this time, we are living inside it. It is the one part of the Earth's story where we are not merely spectators, but authors, for better or worse. But let that be a thought held gently, not a weight, as you drift towards sleep. The deeper truth of this chapter is simply this: the Earth is alive, in the grandest sense, restless, dynamic, endlessly cycling, still making and remaking itself, exactly as it has for 4.5 billion years. The ground that feels so still beneath you is drifting. The rock is churning. The air and the water and the carbon are endlessly moving. The thin film of life clings and cycles and endures. You are lying on a living planet, in the middle of its ongoing story, tonight. So rest on the restless earth, the drifting plates, the deep churning heat, the thin bright film of life, the great cycles turning slowly through the air and the rock and the sea. It is all still happening, right now, beneath you and around you. In the next chapter, we will look ahead, gently, to where all this is going, the deep future of the Earth. For now, breathe slowly and rest on the living, breathing planet. The story of the Earth is not over, not by a long way. We stand near the end of the part that has already happened, but the Earth has a vast future still ahead of it, and we can see the broad shape of it, written in the same slow laws that have governed the whole tale. So let us look ahead, gently, into the deep future of the world. Not with worry, for all of this lies further off than the mind can truly hold, but with the same calm wonder we have brought to the deep past. In the nearer deep future, over the next tens and hundreds of millions of years, the great engine of plate tectonics will keep on turning, as it always has. The continents, still drifting, will keep rearranging the map of the world. The Atlantic may stop widening and begin to close. The continents will drift back toward one another, and in perhaps 200 or 300 million years, they will gather once more into a new supercontinent, a future Pangea, a single great landmass that no human eye will ever see. The map we know is just one passing frame. The drifting will go on, gathering and scattering the land long after we are gone. Mountains we know will wear away to nothing. Mountains not yet born will rise. Further ahead, the deepest changes come not from the earth, but from the sun. For our star, though steady and reliable across all of human time, is very slowly changing, growing gradually brighter and hotter as it ages, as stars do. It is imperceptible on any human scale, but over hundreds of millions of years it adds up. And in perhaps 1 billion years or so, the sun will have brightened enough that the earth grows too hot for its oceans to endure. The seas will slowly evaporate. The water that has covered our world for over 4 billion years, rising into the sky, and in time, being lost. Long before the sun itself dies, the earth will likely become too hot for the life we know. Its oceans gone, its living film at last worn away. The blue planet will not stay blue forever. And then, far beyond that, in about 5 billion years, comes the ending we followed on another night, from the sky's side, the death of the sun itself. As we saw, the aging sun will swell into a vast red giant, swallowing the inner planets, and the Earth, if it still remains, will be a scorched and lifeless cinder beneath a sun that fills half the sky, before the sun sheds its outer layers and fades to a cooling ember. The Earth's story and the sun's story end together, as they began together, out of the same ancient cloud of dust. That is the true far horizon of our world, distant almost beyond meaning, but real and written in the stars. It sounds bleak, told plainly, and yet there is a deep calm in it rather than dread, for the sheer scale of the numbers holds it gently at arm's length. 1 billion years, 5 billion years. These are spans against which not just our lives, but our entire species and all of recorded history are less than a single grain of sand. The Earth has been here for 4.5 billion years and has that much future or more still ahead. Nothing we need ever fear lies anywhere near that horizon. It is simply the natural shape of things that worlds, like stars and like living things, have their beginnings and their long middles and their far-off ends, and that even the ground beneath us is part of that same great cycle of coming to be and passing away. And there is something quietly beautiful, too, in knowing the whole arc, beginning, middle, and end, of the world we live on. Most creatures that have ever lived knew only their own moment. We alone, in our brief flicker, have worked out the entire story, where the Earth came from, what it has been through, and where, in the fullness of the deepest time, it is all headed. To hold the whole life of a planet in your mind, from the dust it formed from to the cinder it will become, is a strange and wonderful thing to be able to do, even as you lie here in the dark, drifting toward sleep. So rest in the deep future of the Earth, the continents gathering once more, the slow brightening of the patient sun, the far-off horizon where our world's long story finally closes. It is unimaginably distant, and there is peace in that distance. In the final chapter, we return all the way home, to the ground beneath you tonight, and the whole vast story it holds. For now, breathe slowly and rest in the calm of the deep future. And so we come home, all the way back from the deep past and the deep future to the ground beneath you tonight. We have followed the whole life of the earth, from a cloud of dust, through fire and collision, through the coming of the oceans and the first stirrings of life, through the poisoning of the air with oxygen and the freezing of the whole world to ice, through the explosion of animals and the greening of the land, through the age of giants and the falling of the sky, through the rise of the mammals and the coming of the ice, and, at the very last, ourselves. 4.5 billion years, and it is all still here beneath you right now. For that is the quiet marvel to end on. The ground you are lying on is not a backdrop. It is the oldest thing you will ever touch, older than any living thing, older than the oceans, nearly as old as the sun itself. The rock beneath you has been part of this planet's whole long story. Its atoms were forged in dead stars and gathered into the young Earth. They may have been part of an ancient seafloor or a mountain long since worn to dust, or the mud of a carboniferous swamp, or the bed of a vanished sea. The very stone under you tonight is a page, many pages, of the story we have been telling. You are resting on 4.5 billion years of history, and you are not separate from it. You are made of it. The calcium in your bones, the iron in your blood, the water that fills you, the carbon of every cell, all of it came from this planet, cycled up out of the rock and the sea and the air, borrowed for a little while to make you, and one day returned. You are not a visitor on the earth. You are the earth, a small piece of this ancient world that has gathered itself together and stood up, and, for a brief, bright moment, become aware. When you touch the ground, the planet is touching itself. When you look at the world is, through you, looking at itself. Think of everything that had to happen for you to be lying here tonight. The dust had to gather into a world. The world had to be struck just so to gain its steadying moon. The oceans had to come, and life had to stir in them, and survive the poisoning of the air and the freezing of the whole planet, and the great dying, and the falling asteroid. Every one of those catastrophes survived. Every one of those thresholds crossed in an unbroken chain across 4.5 billion years, so that this ground and this life and you upon it could exist tonight. Not one link in that chain ever broke, and here you are. The earth asks nothing of you for this. It simply holds you as it has held every living thing across all those ages, on its ancient, patient, restless surface, under its thin sky, in the gentle grip of its gravity. It held the first microbes in the warm early seas, and the trilobites, and the great ferns, and the dinosaurs, and the mammoths, and every one of your ancestors back to the beginning of life. And it holds you now, tonight, exactly as it held them, the same old ground, the same faithful planet, cradling one more small living thing through one more night. So let the whole vast story settle over you now, and let it be a comfort rather than a weight. You are lying on the oldest, most enduring thing you will ever know, a world that has survived fire and ice and catastrophe beyond counting, and gone on, and will go on. It carried life through every disaster and always brought it back to green and blue. It has been patient beyond all imagining, and it is patient still, holding you gently in the dark tonight, as it has held everything that ever lived. Rest now on the ancient ground. The whole story is beneath you, 4.5 billion years of it, and it has led through every fire and every freeze to this quiet moment. You, safe and held and drifting toward sleep on the living earth. Let the planet hold you. It has been doing this a very long time. Good night. Rest on the old, patient ground where the whole story is and always has been, right beneath you.